Today we are starting Unit 9, it's our last unit, on sample spaces and probability. So we've got a little bit of vocabulary first. An experiment is a situation involving chance that leads to outcome results called outcomes. An outcome is the result of a single performance or trial of an experiment. An event is one or more outcomes in an experiment. A sample space is the set of all possible outcomes in the experiment. And we can represent the sample space several different ways: an organized list, a table, or a tree diagram. I personally prefer a table because it's the way that you make sure that you have all of your options and don't skip over things, especially when you are dealing with larger possible events or outcomes. So first off, we are dealing with a two-stage experiment or two-step experiment. And our first example of a two-step experiment is tossing a coin twice. So remember that when we toss a coin, there are two options for that toss. We have heads and we have tails when we toss a coin. And we can represent, we want to represent that those coin tosses using an organized list, a table, and a tree diagram, and figure out how many possible outcomes we have. So when we use an organized list, I recommend starting with one of your possible options and doing all possible options that start with that outcome. So heads, and then we could have heads again on the second toss. So this is the first toss, this is the second toss. On the first toss, we could have heads. On the second toss, we could have tails as another option. We could also have tails for the first toss and heads for the second toss. And we could also have tails for the first toss and tails for the second toss. So that gives us 4 possible outcomes for tossing 2 coins. So a table looks kind of like a Punnett square. So we have 2 possible outcomes for the first time we toss a coin. And the first thing that we do is always going to be on the left. So we have heads and tails for the first coin toss. Second thing we do is always going to be on the top. So we've got heads and tails for the second coin toss. And then do this like a Punnett square. So we got heads, 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 tails, tails, heads, and tails, tails. And then the tree diagram. First toss, we could have heads or tails. And then we need to do the possible outcomes for the second coin toss. And we're going to branch off of the first coin toss. So we've got heads or tails as possible outcomes for the second coin toss. And then we need to write out our sample space. So we've got heads, 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 then tails, tails and heads, and tails and tails. So that example and this next one are two-step experiments. Anything with more than two steps is called a multi-step experiment. So on our next one, we have a coin being tossed. So coin being tossed again, possible outcomes are heads or tails. And a die being rolled. So when we roll a die, it's a standard die. We've got 1, 2, 3, 4, 5, and 6 as our possible outcomes for the die being rolled. We want to represent the sample space. Again, an organized list, table, and a tree diagram. So on an organized list, we start with the first thing, which is a coin toss. Or a coin toss. And we can have heads. And then our second thing that we did was roll a die. And we can have 1 through 6 for that as an option. So we have heads 1 is one set, heads 2 is another set, heads 3 for another set, heads 4 for another set, heads 5 for another set, head 6 for another set. And that's just having heads as our first coin toss. You could also have tails, and then a 1 being rolled, tails and a 2 being rolled, tails and a 3 being rolled, tails and a 4 being rolled, tails, a 5 being rolled, or tails and a 6 being rolled. And that gives us 12 possible outcomes. So again, when we are dealing with a table, the first thing you do goes on the left. The second thing you do goes on top. So we could have heads 1, tails 1, heads 2, tails 2, heads 3, tails 3, heads 4, tails 4, heads 5, tails 5, heads 6, tails 6. And then we go to our tree diagram. So a tree diagram, you start with your first stage or your first step of your experiment, and that was our coin getting tossed. So we could have heads or we could have tails. Then we start to our second step, which was our die being rolled. We could have 1 through 6 on each of these. And yes, we need to draw our branches. And then we have our sample space. So we had heads 1, heads 2, heads 3, heads 4, heads 5, and head 6. We also have tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Next up, we are looking at the fundamental accounting principle. Which figures out how many ways or possible outcomes there are for a notably larger sample space. So one example using the fundamental counting principle is choosing an outfit. And let's say that an outfit consists of a shirt, a pair of pants, and a pair of shoes. So that's our definition for an outfit for this problem. Each time you get dressed, you must select an outfit for the day. You have 20 shirts, 20 different shirts, 12 different pairs of pants, and 5 different pairs of shoes. Choose from how many different outfits are possible. So we have 3 spots we need to fill. We have a spot for a shirt, a spot for a pair of pants, and a spot for a pair of shoes. We have 20 different options for the shirt, 12 different options for pants, and 5 different options for shoes. And we're going to multiply them. Now notice that I put a spot down for everything I needed to fill in, and then filled in how many different options I had for each of those spots. So 12 or 20 times 12 times 5 gets us 1,200 possible outfits. Possible different outfits. Our next example, Marcos recently started working at the Lufkin Burger Shack. Marcos asks each customer at the drive-thru questions from a script. What size burger would you like? Kids, regular or large? Would you like cheese on that? Would you like lettuce and or tomato? What would you like to drink? Water, soda, sweet tea, regular tea, lemonade. So we have 4 different spots because we have 4 questions, 4 blanks. Our first one is what size of burger? Kids, regular or large? So there are 3 options for that. Would you like cheese on that? So that means that they could have cheese or not have cheese. So that's 2 options for that blank. Would you like lettuce and or tomato? So on this one, they could have lettuce, they could have tomato, they could have lettuce and tomato, or none. No lettuce and no tomato. So that's 4 options. Then would you like a drink with that? So water, soda, sweet tea, regular tea, lemonade, or no drink. So that's 6 options for that one. So 3 times 2 is 6, times 4 is 24, times 6 is 144 possible outcomes. Our next example, a die is rolled 5 times. Find the total number of possible outcomes from this task. So we are rolling 1 die 5 times. So we've got 5 spaces because we're rolling the die 5 times. Now, how many options do we have on a standard die? 6, because we have 1, 2, 3, 4, 5, and 6. So for the first die roll, we have 6 possible outcomes. For the second die roll, we also have 6 outcomes that can happen. For the third die roll, again, we have 6 possible things that could happen. For the fourth die roll, again, we could have 6 different outcomes. And on the fifth die roll, we have 6 outcomes. So that is 6 to the 5th power, 6 times 6 times 6 times 6 times 6 is 6 to the 5th power. And 6 to the 5th power is 7,776 possible outcomes. Our next example, we want to consider the list of numbers 2, 4, 6, and 8, and how many unique 4-digit numbers can be made from this list. So this one says that we can repeat, so we need to figure out how many different numbers we have in here. And we have 4 different numbers. Now we are trying to find the 4-digit number, so we've got 4 spots to fill. And on the first option, we have 4 numbers to choose from. Now let's say that number goes back in our bag. We still have 4 numbers to choose from for the second number. And again, that goes back in our bag. We still have 4 numbers to choose from for our third number. And again, that goes back in our bag, and we still have 4 numbers to choose from for our fourth number. So this is 4 to the 4th power. Which equals 256. Possible outcomes are possible 4-digit numbers. And then our next one, the last one on the notes, we want to consider the list of numbers 2, 4, 6, and 8 again. So again, there's only 4 things in here. You do want to make sure that you are counting how many possible numbers or digits are in your list. How many unique 4-digit numbers can be made from this list? So again, we have 4 spots where we cannot repeat a number. So this time we can have one of the numbers, any one of those numbers. So let me get you an example on this. So say we're drawing numbers out of the bag. We've got 2, 4, 6, and 8 in that bag. So we've got 4 different numbers to choose from for the first draw. So let's say that we drew the 6 on the first one. For the second draw, we only have 3 numbers left to choose from. Say on that draw, we drew a 2. So we only have 2 numbers left to choose from. And say we drew the 8 on that one, and we have 1 number possible left to choose from. So we've got 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is also 24. So we've got 24 possible 4-digit numbers. If you need to draw a bag like I did and help you figure out what the problem is asking you for, I highly recommend it.